So now in this video, we're going to look at a test circuit that I actually talked about in great detail in the last video. We're going to do a quick review of it. So we have a PNP bipolar junction transistor right here, and it's conducting pretty well because we got enough supply voltage, 4.2 volts. When we lower the voltage, it will start turning off. So I have a stack of voltage drops, about 0.6 volts from emitter to base, about 2.5 volts for a green LED at low current. It drops more voltage at a higher current, and a Schottky diode in series with those two over there, which has a forward voltage of about 0.3 volts. So you would think at 3 volts, all of their voltage drops would be enough to get the transistor to turn off completely. But as you can see, it does not. Now, I can, because current does trickle through semiconductors, even when you get, below their forward voltage. So I got a 10K resistor that I can put to the positive supply, and the LED is blocking my view. I actually thought I felt it slide into a slot. Okay, there we go. I stuck that to the base, and now we got a much dimmer glow right there. And so if you're using a lithium ion battery, that's 2.9. I think we still have a little bit of a glow. Yeah, you can see a little bit of a glow there. Looks like about 2.8. We don't have any more glow for the bright LED at that point, which is our goal. We still have a little bit of current going through that green LED. We're going to measure that in this video. And if I slide this over, then you can see that one's off. But if I yank the 10K resistor, now we have a glow. So I'm thinking there's a lot more current going through that LED than that one, just because it's a higher wattage LED. And so I figure we will grab the multimeter and actually measure the total circuit current when I don't have that resistor and when I do have the resistor. First we'll measure when I do have the resistor. So now I shuffle the components around. Hopefully you can see it better. Right there, we got the emitter up on top there to that jumper, and I moved the bright LED down a little bit, and that 220 ohm resistor, because we need a fair amount of base current to turn this on, is coming to the middle pin right there, as is that 10K resistor. So we're going to measure the current, and first thing I'm going to do is open the circuit. You need to open the circuit to measure current. We're going to look at total circuit current, and interestingly enough, the green LED is still lit. Oh, because we have that 10K resistor going through there. I forgot about that. So we have that. It's giving an easier path than the emitter was for passing current. So we will come back and set the meter to measure current. So first we're going to start with milliamps, just to be safe. And that really, I forgot about that 10K resistor. So what I'm going to do is put the 10K resistor with the emitter up here. So that will work as well. The emitter was connected to the positive supply, and the pins do not want to go in right now. They're a little jagged. I'm going to straighten them. So now I got the resistor at the emitter, and then also at the base right there. So both the emitter and this side of the resistor were going to the positive supply, so they were connected together anyways when we had that jumper. And there you can see the positive side of our LED module is at the collector. And we'll zoom back. So I do not think we'll be in the milliamp range, but we'll test that out. So this is with the 10K resistor. So we got to complete the current through the meter right there, and it's saying a 0.04 milliamps. That's kind of what I was expecting, and we can check that in microamps. So that's the current going through the green LED. So I'm bringing the red probe to the positive supply. I could go to where this jumper is right there, if that's easier to see. Trying not to make a short with the supply. And then you can see about 40 microamps, which is the same as 0.04 milliamps. So that's how much current we got flowing when we use the 10K resistor to help turn off the PNP bipolar junction transistor in this case. And now we got rid of it, so it's easier for current to leak through and go. I should have stuck it to milliamps, but we saw that it was less than 1 milliamp right there, about 0.3 milliamps, 332 microamps right there. So yeah, we have about 9 times as much current flowing when I don't have that pulled down resistor, when I'm trying to get it to shut off at a low enough voltage. So I'm done measuring current now. I'm going to get the meter off and measuring current. It's safe to have it for set on voltage if there's a power button, but since there's no power button, I have an off setting. I just set it to off anyways. So now, the main takeaway is when I drew this diagram, I hadn't, built the circuit to the standard that I should have. We are at 2.8 volts right now. I really wanted to shut off at 3 volts completely. Of course, we can avoid a little bit of leakage in this video, but anything above 2.5 volts is fine. So even 2.8 volts is not too bad, but we have a bit more leakage current than I want. That's mostly going from emitter to base. That's turning the transistor on a little bit. It's called the active region. That little bit of current from emitter to base is setting how much current is going to flow through emitter to collector. But if I take and don't touch this, if it's bright, because it will be really hot. But if I put that resistor to the positive supply, so it's easier for current to go through that resistor, but it's going to the base. It's not traveling through emitter to base. It's just going right to the base. So it doesn't make the transistor conduct at all. It'll cut off the LED module there completely, as you see there. So it's a little easier to go through the green LED. Green LED lights up a little bit more, but it's only passing about 0.04 milliamps of current instead of about 0.33, I think it was, for the LED. So we're wasting about 1/9, 1/10, something like that, the amount of current that we are wasting when we have this. So if we have a battery, we're trying to not discharge anymore. This is gonna, slowly discharge it, but not near as slowly as this. So that's it. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.